Good morning. Today we are going to learn about interview questions of VLSI DFT. First question is, if we provide a controllability and observability to the ports of area under test, will it improve the test coverage? If yes, how much percentage of improvement can we see? Obviously, the answer is given in the question, yes. Yes, we can see the improvement in the coverage. Think about the bounding logic that we are usually give for macros. So the improvement can be depends on the logic which is connected to it. The improvement in coverage will depends upon the initial coverage without bound and the number of faults in the design under test. Okay. My next question is, when both, this is important question, when both transition delay and path delay target for transition faults, why should we have two different methods to detect the same? The question is, transition delay, path delay target the same faults. So before going to read the answer, first we should know about what is transition delay and path delay. So actually this transition delay, suppose this is the logic. Let us assume this is the logic. Some logic is here. Some logic is here. So this transition delay related to particular node. And path delay is related to entire path. Okay, now we'll read out the answer. Yes, both the transition delay, path delay will target the transition faults. That means 0 to 1 or 1 to 0. 1 to 0. But they are different in the following ways. Transition delay is related to slow to rise, slow to fall at a particular node, transition delay. Whereas path delay is related to slow to rise, slow to fall for a particular path from here to here, particular path. So the reason for transition delay at particular node is some manufacturing defects at that node. Manufacturing defects at that particular node. The reason for path delay is some manufacturing defect that is distributed throughout the path. Okay, we'll explain this one. I made a separate video for this one, so we just go through it. So now it is more resistive path. It is more resistive to node, particular node. Okay, so in case the transition delay is related to this particular node only. So we don't know if you do the transition delay first, the path will take here the path is not defined by us, so it will take critical path or some other path what we don't know. But in case of path delay, so we are going to define the starting flop and ending flop, starting and end points, so that we should know about the path which is the path is passing. Next question is, if for a production set we have both path delay, transition delay patterns, which scheme should be done first? First of all, I want to erase this one. Yeah, here the question is that if for a DFT production set, we have both path delay, transition delay patterns, which scheme should be done first? It always better to do the path delay first, then transition delay. In my previous question, I explained this. It is always better to do the path delay first, then transition delay. Path delay, start flop, end flop are given by the user. The transition go through well-defined path, more effective. Transition start and end flop. End flop is decided by the tool. So the transition may happen through a shorter path or longer path. We don't know. It is less effective. Path delay basically target all the critical paths in the design. All the critical paths in the design. Generate the path delay patterns for all the critical paths in the design and write down the faults for the same. First, we will generate the patterns for path delay. First, we will do the path delay testing first. Then we will go for the transition delay. Generate the transition delay patterns by loading the faults in the path delay, which are read before, such that faults detected in the path delay are not retargeted. The major reason to follow the above sequence in the transition delay, we are not sure whether a transition happened really through the critical path. So that's why we are not doing the transition delay first. We will do the path delay first, then we will go for the transition delay. If you do the transition atpg first, listen, this is a transition atpg first. We are not sure whether the transition happened through the critical path. In such a cases, we may not have a pattern which may catch the fault through the critical path, but fault may be detected through the some other shorter path, which may add the faults to the detected list. So it is always better to do the path delay first, then we'll do the transition delay. Next question is, first let me erase this one. Next question. What do we mean by fault simulation in DFT terminology? Simply we can say that simulating the design in the presence of faults. Fault simulation consisting of simulating a circuit in the presence of faults, logical faults. Comparing the fault simulation results with those fault-free simulation of the same circuit simulated with the same applied test, we can determine the faults detected by that test. There are several types of fault simulation techniques such as serial fault simulation, parallel fault simulation, directive fault simulation. My next question is, what is meant by the coverage in DFT terminology? It's the most important. Coverage in DFT terminology. The term coverage can be broadly classified as two types. First one is fault coverage and test coverage. So this is a total number of fault coverage is the total number of detected faults divided by the total number of faults in the design. And test coverage is the total number of detected faults divided by the tested faults in the design. Simply we can say that tested faults by testable faults. Test coverage is tested faults by testable faults. Fault coverage is tested faults by total faults in the design. Here the fault coverage tested faults by total faults. That means testable faults plus untestable faults comes under the fault coverage category. In the test coverage category, tested faults by testable faults, only testable faults. Untestable faults are not considered for calculating the test coverage. Tested faults are the faults in the design that can be tested and observed by the patterns used during the testing. Please note that here the word faults refers to the manufacturing defect, as the DFT does not merely target the functional faults, but rather than focusing on the circuit test. Coverage calculations are used to measure the effectiveness of the test patterns and test generation for the given set of faults. So this is all about today's lecture. So please share and subscribe my channel. We'll meet in the next video.